Hi, I'm Dr. Robin Preece from the University of Manchester, and I'm here to talk to you about how we can future-proof your planet by getting our power systems to net zero. So we're here in the Net Zero Lab at the University of Manchester, and this is one of the teaching labs that we use on our electrical and electronic engineering courses to teach about how we can transition to net zero. So net zero is all about the balance of how much carbon we produce and how much carbon we take out of the atmosphere. And we want to get that to zero, and the UK's pledged to do that by 2050. Now, a big part of that is all about electrifying and decarbonising energy and our energy consumption. And the current government has actually pledged to try and get to green energy by 2030. Now that means all the fossil fuels that we currently use, we need to stop using them and we need to replace them with more and more renewable energies or with things like nuclear, which are much, much lower from a carbon perspective. Now doing that is a real challenge. So a big part of decarbonising our energy is all about decarbonising and electrifying our big sectors like heating and transportation. So at the moment, most cars actually consume fossil fuels, consume petrol, and we're going to shift that over and use electric vehicles instead. But doing that is not very simple for the electricity grid because every vehicle is essentially the same as connecting another house. The amount of energy an electric vehicle uses is about the same as a house. So the grid isn't really set up for that and can't cope with all that electricity. At the moment, only about 1 in 30 cars are actually electric vehicles. So that's a lot more electricity that's going to need to be used. It's basically like doubling the grid, doubling the amount of electricity that we need to get through our power system. And that's a real challenge. And that's just vehicles. If we do heating as well, if we move from using gas boilers to instead using things like heat pumps, that's going to be another doubling of the grid as well. Obviously, we can't build all of that infrastructure at one time, so we have to be cleverer about how we use the electricity we have, how we get that through the networks, and how we get that through to consumers at the end of the day. Now, doing that is a challenge, requires things like smart controls, new types of materials, new ways of controlling things, lots of coordination across lots of different electric vehicles all across the country. And that's the kind of challenge that electrical engineers are solving. It takes things like communications, control, design, sensing, new materials. All of that stuff is stuff that we do. And we've got to do that as well in a way that is safe, secure, green, reliable. So this balance of affordable, sustainable energy is one of the biggest challenges facing actually the whole planet right now. It's not just the UK that's trying to do this, and that's also one of the challenges. The fact that every single country in the world is pretty much trying to address these problems at the same time. That means that there's also struggles with getting like global supply chains in place in order to be able to get the equipment you need, even the skilled workforce. There's just not enough engineers. And so we want you to come to Manchester, train to be an engineer, an electrical engineer in order to solve these problems. But it also means that if you do that, you'll have the skills that will be able to take you pretty much anywhere in the world as well. The good thing is that electricity works the same wherever you are in the world. So here at Manchester, we are solving these kinds of problems. We're working on this. We're doing research here to try and tackle these things. We use our high voltage lab, which is the biggest high voltage lab of any university in the UK. We use that lab to test new materials, to test new products, zap them with 1,000,000 volts and see if they're able to survive out in the real grid. We're using that. We're also using spaces like this to develop new types of control, to see how to control things like solar panels and electric vehicles and to coordinate them all so that they're working together so that we can get the most out of the electricity grid that we've got right now, because it's going to be a challenge to build another 2 or 3 grids in the next decades. And we're working with big companies in the area as well. We work with National Grid a lot, and we work with them to develop more resilient power systems. So systems that are able to survive the kind of climate challenges that we're going to have, more lightning, more storms, extreme wind, flooding, extreme heat. All of those kinds of challenges, we need a network that's able to survive those and keep operating, particularly if we're more reliant on our electricity in the future. So we need engineers to come and future-proof the grid itself. So obviously there's a lot of challenges left to solve with the electricity grid, But that's just one part of electrical and electronic engineering. And if you come to Manchester, there's lots of different ways that you'll be able to help contribute to future-proofing your planet.
We're here in one of the robotics research labs in the Department of Electrical and Electronic Engineering. And you might be wondering how robots can help future-proof your planet and help with the big challenges of net zero. Well, consider the scenario that by 2050, we need 80,000 more wind turbines. That's 250,000 wind turbine blades that need inspecting, 10 million bolts that need maintenance and tightening. To be able to do that with current technologies, we would need a new workforce of 400,000 operators and technicians. And that's just in the UK alone. Globally, we're going to need nearly 200,000 new wind turbines. So if we can't do it with people, what can we do it with? Well, robots are one of the solutions that we're exploring. So these environments that we need to maintain are often in really remote locations, and they're often difficult to access, or the ways to access them are really carbon intensive. If your wind turbines are in the middle of the North Sea, you need to send a big ship, a helicopter. There is a huge carbon footprint associated with that. Imagine a world where robots lived on the wind turbines, that they lived in the nuclear facilities or on the solar farms, that were doing the maintenance and operations with human oversight to make sure that they're doing the correct activities. But that cuts down the carbon emissions, and that keeps the fleet of energy generation assets going. It keeps our lights on. Our world runs on electricity. Our world runs on technology. To secure that future and make sure that it's sustainable for not just your generation, but the next generation, we need to invest in the people, in the skilled engineers. And that's what we do here at the University of Manchester in the Department of Electrical and Electronic Engineering. To build a robot, which is a highly complex system, you need all sorts of technologies. You need motors, you need sensors, you need the software that underpins it all. Now, all of those technologies are used in our everyday lives, from your washing machines to your computers, your phones, your cars. So developing that technology is not just beneficial to robotics, but it's also beneficial to the wider world. And when we developed these robots that are going to help the net zero assets and help maintain them and run them, we can also use them in other areas as well. The UK was a pioneer in the Victorian era of building urban infrastructure. Our road network, our rail network, the sewage system, the utilities, they were all developed as world-leading areas. But now they're aging assets, and they need a significant amount of investment to maintain and to upgrade them. And to do that efficiently, the use of robotics is going to be critical. They can access areas that humans can't. They can monitor things safely, taking people out of harm's way. But they're never going to be fully autonomous. We are always going to have people there behind the robots, building them, designing them, maintaining them, and operating them. And once we've got them in those challenging environments, we can also have wider societal benefits. We can start using those robots in our day-to-day lives, helping us with social care, social assistive robotics, helping us with surgical robotics and healthcare robotics as well. So how robots can help future-proof your planet? Robots in the future will be in every single aspect of your life. But even if you're not interested in robots, the technology that goes into them is critical to keeping our world running. Our world runs on electricity. Our world runs on technology. Engineering is fundamental to this. Be it from the power grids, the networks, the energy generation, through to our phones, electrical appliances, to the robots that are going to help sustain our future. We need engineers to help develop that next generation of technology. That's what we'll train you in. We'll train you in those core technologies that is going to help future-proof your planet and lead to a sustainable future.